So, hello and welcome everyone to my channel. Myself, Soumya Vivek Kumar Trivedi, and I am an undergraduate at Electrical Engineering in BTech in IIT BHU. So, in this video, we are going to take up to another integral problem, which is from a very famous book for GA Advanced, that is Black Book by Vikas Gupta. And so, without wasting our time, let's directly jump onto the question itself. Here, we have been given a function fx as 1 plus some nasty integral here. And the main important line in this problem is nothing but this, but x and y independent variables. Because most of the students who are preparing for GA Advanced will go under the misconception that if this is the function given as fx, then they would instantaneously write fy as 1 plus 0 to 1 2 e power y fy dy. Basically, they will directly substitute y in place of x and will arrive at the conclusion that fy is this. But this is totally wrong, because it contradicts the heart of this question, where x and y are independent variable means the function is of x and y acts as a parameter here. It has no relation with the function of x, which means that this whole thing is not true. And the another proof that this is not true is directly visible, that since fx is given like this and this second integral is in terms of y and the limits are also constant, but the function which is being integrated is a mixture of variable x and y, and it is being integrated with respect to y with constant limits. So this integral will not be constant, it will be something function of x, that is gx, plus 1 is also there, so we can write fx as gx plus 1. So in that case, it is literally visible that fx can't be guaranteed as a constant function. It will only be constant when gx is 0. And whether gx is 0 or not is not yet decided. So we can't directly say that this is always and always an independent constant thing. But this thing here says that fy is constant, which contradicts the assumption or the declaration that we made here. Because the integration here is being done with respect to y. And the whole function which is being integrated is also in terms of y. So this integral, definite integral, is come out to be a constant. Okay. So in that way, this fy will be constant, which contradicts the declaration that we already made. So after clearing this misconception, now we will directly solve this question. So this question by the first glance itself seems to be quite difficult and complex, but literally saying if we just observe it very clearly, then this question is no sort of rocket science, right? So let me copy down the question, that is fx is equal to 1 plus integral from 0 to 1 x e power y plus y e power x into fy, integrating with respect to dy. Okay. So now I'll be just scrambling this function around, that is taking x out 0 to 1 ey fy dy, just taking ex out 0 to 1 y fy dy. Now comes the main part of the observation that I was talking about. Here, this two integrals will always come out to be constant and constant, because they are being integrated with respect to y, and the function which is being integrated is also a function of y. So we can write fx as fx is equal to 1 plus bx plus a power ex. More simplification, then we can write it as a power bx plus c, right? And clearly c is 1 here. So now we are naming this equation as equation number 2. So now if we differentiate this function, that is f dash x, we will be getting b plus a e power x. Let this function be named as 3. Now we will differentiate the original function that we were talking about, that is this. So if I differentiate this, then I'll be getting 0 to 1 ey fy dy plus ex 0 to 1 y fy dy. And now the main thing is, since we have made this assumption, we can say we have simplified the form as 1 plus Vx plus a e power x, then we can also write Fy as a e power x plus Vx plus c, where c obviously is 1, which is already found by us. So in that way, we can also write Fy as a e power x plus bx plus c dy, plus here ex will remain as it is, and inside the Fy will be simplified to a e power y plus by plus c. Okay, this is my mistake here. Let me fix it real quick, because here it will be y, because we are substituting Fy here, right? So now the integration is quite simple. Here the integration is of a e power 2y from 0 to 1, which will directly yield a by 2 into e power 2y goes from 0 to 1, which is nothing but a by 2 into a square minus 1. And then comes this integral, that is b e power y integral 0 to 1. Now this integral you'll have to solve with the by parts method. And it's quite easy to solve, so I'm not wasting any time and I'll be writing direct solution of it. So it will be nothing but b itself, because here 0 to 1 e power y dy will give us 1 only. So this becomes plus 1 plus b, and then comes the integral of 0 to 1 c e power y dy, and this c e power y dy will give us c into e minus 1. So the first coefficient, that is the coefficient of 1, is nothing but a by 2 b square minus 1 plus b plus c into e minus 1. Now we'll be solving the next bracket right here, which is the second one. So wait a minute. E power x will remain as it is, and inside this will be the integral of a y e power y 0 to 1, which will similarly yield nothing but a. So it is a here. Then there is integral of by square, which will lead us to b by 3, since the integration limits are from 0 to 1. And then the last integral is of cy, which will lead us c by 2. So now let this equation be named as equation A. Okay, so sorry it was not visible due to my face cam. Now you'll be able to see that second bracket has been evaluated like this and first bracket has been evaluated like this. I will be giving you summary once again. First of all, this is the main function. Let me change the pen itself. This is the first function, not main function. Then we just open it up and assume this function in the form of fx 1 plus bx plus a e power ex, where I put up 1 as c and c will be equal to 1, right? And then I took the derivative of the whole function, which came out to be the equation 3 itself. Then I took the derivative of the original form. Original form was this, and when I derivated it, I came across these two integrals. First integral this, second integral this. In this we have been integrating the function in terms of y, and since we can write fx as c plus bx plus a e power x, we can also write fy as c plus by plus a e power y. So I wrote down that two substitutions, and after integrating that thing, the f dash x came out to be this final thing. And we had already calculated f dash x in the simplified form. That is nothing but f dash x is b plus a e power x, right? So since these two things are same, now we can directly compare the coefficients of e power x and the constant to this equation. And then we'll be able to find the values of a, b, and c. C is obviously 1 that has been found out very earlier. So here the constant is b. So we'll be putting up a by 2 e square minus 1 plus b plus c into e minus 1 as b. Now we already know that c is 1, so this is 1. b will get cancelled out. So a by 2 e square minus 1 is equal to 1 minus e. That gives us a is equal to 2 upon minus 2 upon 1 plus e. Since this will cancel out to be minus 1 plus e, right? So this is the value of a that we have got now. We also know the value of c to be 1, right? So the only value remaining is of b, which can be found from the comparison of the second coefficient, that is coefficient of e power x, that is a is equal to a plus b by 3 plus c by 2. A gets cancelled out, c is 1, by which we can say b is minus 3 by 2. Spot on. So now we can write the original function as fx is equal to a into e power x, that is minus 2 e power x upon 1 plus e minus 3 by 2x plus 1. So finally, after so many hustle, we have finally found what really fx is. Now since we have found what really fx is, now we'll be able to solve the first and second problem of the paragraph very easily. So here, the first question says that if the complete set of solution of x for which the function fx plus 3x is strictly increasing from minus infinity to k is this, then find this thing. So for this being completely increasing, its derivative must be positive, which should be positive, which gives us that f dash x should be greater than minus 3. So now let's just plug in the equation. Now we'll be able to get f dash x as minus 2 e power x upon 1 plus e minus 3 by 2 to be greater than minus 3. So in that case, it will be minus 3 by 2 smaller than minus 2 e power x upon 1 plus e, or we'll change signs and also the side, that is be looking like this. So now we can say that e power x should be smaller than 3 by 4 into 1 plus e. Sorry. So since e power x is more than 3 by 4 into 1 plus e, so e power x belongs to minus infinity to this thing, right? And we have been asked the value of e power k. So we can directly plug in as 4 by 3 into 3 by 4 into e plus 1, right? So now this will get cancelled out, and e plus 1 is 2.7 something something plus 1, which is 3.7 something something plus 1. And the GIF of that will give us 3. So the final answer for the first question is nothing but 3 itself. Okay. So now we'll be moving towards the second question. Second question is also pretty simple. It is saying that if acute angle of intersection of the curves x by 2 plus y by 3 plus 1 by 3 plus 0 and y equal to fx is theta, then find tan theta. This is the standard 2D geometry question. First, we'll be able to find the direct intersection solution of this two graphs is y is equal to fx, and here y is equal to minus x by 2 minus 1 by 3 whole into 3. Okay, so we'll be able to find the point where these two graphs intersect. And I'm saying that we will be able to find because it is quite clear and it is quite visible that these two equations are literally solvable. Because if you write y is equal to fx, we have already found fx, which is minus 2 e power x upon 1 plus e minus 3 by 2x plus 1. Now if you equate it with the y of this function, that is minus 3x by 2 minus 1. So I was literally saying that I will be able to solve it because I had already got an idea that minus 3x by 2 and minus 3x by 2 will get cancelled. So we'll be getting e power x upon 1 plus e as minus 2 by minus 2, which is 1. So e power x is 1 plus e, which will give us x is equal to ln of 1 plus e. So they both, means this both graph intersect on a point where the value of x is equal to ln of 1 plus e. So now the equation is quite simple. We will find the slope of both the graphs at this point and will then use the formula, the standard formula for finding the acute angle, that is tan theta is nothing but mod of m1 minus m2 upon 1 plus m1 m2. So m1 here will be the slope of the line, which will be the constant because it is a straight line, and the slope of this line is nothing but minus 3x by 2, which is quite visible. So minus 3 by 2. And now we'll be finding the slope of the curve at the point ln of 1 plus e. So let's derivate the function right here. minus 2 e power x upon 1 plus e minus 3 by 2. Now we'll plug in the e power ln of 1 plus e upon 1 plus e minus 3 by 2, which will give us minus 2 minus 3 by 2, which is minus 7 by 2. So in that case, we are getting m2 as minus 7 by 2. Now, the only thing that is remaining is directly plugging into the formula, which I will also do right now. Is minus 3 by 2 plus 7 by 2 whole upon 1 plus 21 by 4, which gives us as 4 by 2 upon 25 by 4, which is equal to, wait a minute, 8 by 25. So the acute angle is theta between these two curves intersection point, and the tan theta value comes out to be 8 by 25. So let me see if the option is there in the question itself. Okay, so there here it is 8 by 25. So our final answer for the second question is option number A, that is 8 by 25. So in this way, the whole problem is solved. So my main advice for this kind of problem is that just use your keen observation, be calm while attempting the question. And even if you get the idea of how to solve this question in just 1 second, then also just keep calm and be focused while solving the whole problem, because this kind of lengthy problems can sometimes trouble you by making you do silly mistakes, and then you will lose marks even though you had figured out the concept in just 1 second. So that's all for today. Now we'll be meeting in the next video where I will bring another mathematical tough problem, which will be somewhat useful for you if you're preparing for JEE Advanced or any other sort of exam, even for the enjoyers of mathematics. I'll be coming sooner or later. So that's all. Goodbye.